me well. I want to welcome you to this class. And this is our fourth class. And I'm happy that we are still moving on well up to now. And I want to thank those who are joining us. Thank you for being part of this group. And I hope that you can be able to catch up with what we've been looking at. Now, those who are joining us, please, our previous work can be got from our Google Classroom, of which details I think we shall avail to you towards the end of the lesson. So I want to thank all of you for coming, and I want to thank God for keeping us alive till now. And as we get started, as usual, we needed to get started with a simple word of prayer from one of us. And do we have a volunteer, someone who can volunteer to give us a word of prayer then, so that God can guide us through this lesson as we proceed? Yes, Katongole, you can unmute and then you give us a word of prayer. Yes, Katongole.
Good morning, teacher.
Yes, good morning.
Let's humble ourselves for the word of God. Dear Father God, we thank you for the gift of life. We thank you for the wisdom, for the protection you've given to us. We pray that you guide us through this lesson and enable us understand what the teacher is going to take us to do. In Jesus' name we pray.
Amen. Okay, thank you so much, Katongole, for the prayer. And as we keep on waiting for our friends to come in, I want to just review a few things that we've been looking at. And those of us who have just joined in, we are looking at probability. Okay. Probability is what we have been looking at. And under the probability, we had started on to looking, knowing that we started by looking at the formula, knowing that probability of a given event is equal to the probability, to the number of the event out of the number of the sample space. Now that is the basic formula that we need to have at the back of our minds as we work out several numbers. Now, we also saw how we can handle certain events and different type of events. And last week, we were looking at tossing a coin, okay? We started by looking at what happens when we toss a coin. And we looked at tossing a coin once, twice, and also 3 times. That is what we basically looked at. And in our review, please, we are just reviewing what we looked at here last week. Those who are just joining us as wait for our members to come. Now, we also say that when you're tossing a coin once, you always have 2 possible outcomes. Now, remember, a coin has a head or a tail. Now, once it has that, it means that when you toss it once, you'll either get the head or you'll get the tail. That is when you toss it once. But when you toss it twice or 2 times, we saw that you will always get several outcomes. You'll either get a head and a tail. This is the first time. And when you toss it the second time, you'll also get either the head or the tail. Then this side also you'll get the head or the tail. Now here, when you see the possible outcomes here, you have here a head, Then here you also have head, tail. Then here you also have tail, head. And here you also have tail, tail. So meaning our possible outcomes, when we look at here, when we look at our possible outcomes here, and these are our possible outcomes. Okay, we have head, 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 tail, tail, head, and then tail, tail. So meaning the number of outcomes is 4. That is when you toss it twice. This is the first time, and then this is the second time. Then we also saw that for once, you have only 2 outcomes. You have this one, and then we also have this other outcome. All right. So please, as we enter, let's see, focus through, let's check through, let's focus here. So okay, as we check on, we are saying this is what happens when you toss your coin once, and then this is twice. So once you have 2 outcomes, twice you have 4 outcomes. And we also say that you can use either the tree, the probability tree, okay, these ones that I've drawn, or you can use the probability table, okay? You can use one of them. Now, we also saw that when you're trying to work with 3, if you're working with the 3 coins, if you're tossing 3 coins, okay, if you have 3 coins, or if you're tossing 1 coin 3 times, it is the same. We get the same outcome. Though the table will bring us this, and then the other probability tree will give us this other. We shall use this other method for doing that. So we said when you toss 3 coins, if you have 3 coins and you're tossing them, or 1 coin you're tossing it 3 times, the possible outcomes here, first, in the first tossing, you'll have head and tail. In the second tossing, this is what you have. Okay, you'll have now here head, tail. Then you also have here head, tail. Then in the third one, you will also continue with this. Okay, we shall also keep having, this is the third tossing. So you'll also keep having head, tail, head, tail, head, tail, head, tail, head, tail. So here you can now generate the possible outcomes. And generating the possible outcomes, we generate them by following this given route. So when you look at this, head, head, head. So meaning this is the first outcome, the possible outcome. The second one, you have head, tail, head, head, tail. So you have this. So you keep on generating your outcomes in that form. Head, tail, head. Then here you also have head, tail, tail. Then we also have tail, head, head. Then we also have here tail, head, tail. So we have tail, head, tail. Then here we also have tail, tail, head. Tail, tail, then the head. Then here we also have the tail, tail. So literally to get the possible outcomes, these are our possible outcomes. So you count how many they are. Here you have 1, 2, 3, 4, 5, 6, 7, 8. So meaning your possible outcomes are 8 in number. Okay, so literally this is the how we shall be able to, okay, this is how we shall be able to work up through when we are working with our coin. Okay, all right. Some people are not hearing anything. How come? Okay, please, let's utilize the chat for communicating here, this other side. Otherwise, you may not pick up anything. Otherwise, I may. Okay. Okay. So I'm trying to check out. Please, in case there is an issue, you can raise it up here. Some people say are not hearing. I hope we are all hearing now. Please, I want also to increase the, let's also increase the volume of our devices. Let's increase the volumes of our devices. Okay. So literally, this is what we've been doing. Those of you who have just joined us, it is what we've been usually carrying on. Let me try to answer through some hands, those who are here. We are reviewing what we've looked at. We have not started the work yet for today. Now, some of you, if your device is not well labeled, I may not call your name out, okay? Your device should be labeled with your name. So that's why if you raise your hand, I don't pick you up, it means that your device is not well labeled. So let me start with Donald. Donald. Yes, Donald, can you unmute? Your hand is up. Yes. We are not getting you well. We did what? You have made the mistake on the first sentence. Head. We say the former space is what? It is head, not head. Which one? The first one? Yes, the first one is head. Okay. Yes, it is this, head. Okay, noted. Okay. Thank you. Let me see another person. Gilbert. Chigango Gilbert.
Yes, sir. Yes, sir. Thank you, sir. I want to know how you have got the outcomes in the last column. These 8 outcomes. How have you got them?
Now, do you see? Check. I don't know if you can look through this. You check this screen. We are saying that when you're tossing out, okay, when you're tossing out your coin, remember the coin is one, and it has only 2 faces, and you're keeping on throwing it up 3 times. So in the first throw, you get this one and this. This is our first throw. Okay. In our second throw, this head here will produce 2 outcomes, and the tail will also produce more 2 outcomes. In the third throw, the other one will also produce outcomes here, and also this one will also produce outcomes. So this is literally, we have the throws are, this is 1, this is the second throw. So the second throw takes on this one here. This is our second throw. And then this is our third throw. Okay, that will be our third throw. So this is how we are coming up with this. So this is first, in the first throw, you will come up with this. So when you're coming up with these other outcomes, look at the line, look at them in line. So when you look at our in line, we see that this one here, in our first throw, we look at the first throw. That's why you are coming up with 3 heads. In the second outcome, we had head, then also tail. That's when you're coming up with this. In the third one, remember we are originating, there's somewhere we are originating from. Okay, don't leave out that. In the third one, we are still starting with our head, we come to tail, then head. This is what we have. The fourth one, we have head, tail, then we raise this. So you start from the very first one, then we keep on moving on like that. Then after this one is done, then we also have this. We have tail, head, like that. And that's how you produce that. Then another one, we have tail like that. So when you see that, you're moving all that, that's when you see that. That's how the outcomes are coming about. So that's how we are coming up with these given outcomes of the head, tail, head, and so on. Okay, Fahia and Halima, you're on stage. Okay. Mary? Yes, Mary.
Teacher, is it the number of coins were given that it's the number of time you toss it?
Yes, please. Yes. If you have 3 coins, meaning you're tossing 3 times. If they say, because if they give you 3 coins, it means you're tossing them 3 times. If they give you 2 coins, it means you're tossing them 2 times. Okay. If they say 3 coins are tossed, means they have been tossed 3 times. Or if they say that you are given 3 coins and they are being tossed once, okay? Meaning that is what we do have, meaning you're doing the 3 coin part of it. Okay, Jace. Yes, Jace?
Excuse me, sir.
Hmm.
I was asking, why is it, because they had told us to toss 3 coins, can't we toss them at once and record those? Or why we have...
Thank you. I've got your question. Now, Joyce is asking, you have 3 coins. Why are you tossing them one? If you have 3 coins, Now, as I told you, we are using 2 methods. We have the probability tree. The tree works for 1 coin being tossed 3 times. Okay? While for the table works for 3 coins being tossed at once. Okay, so meaning what you do for the other one, remember, if you remember our table for the other ones for throwing it, we had you bring it like this: head, tail, then we have tail, head, and then tail. This is the 2 coins. So this happens. Someone was asking, why don't you throw them at once? Yes, you can throw them at once. Okay, so this is what you will have when you do that. So in so doing, it means that here you're going to have the 2 coins, and then the 1 coin will be up here, head and then tail, and then you will throw them. Meaning this is here you're doing it at once. I don't know if we are together with that. The table will show that you're getting those 3 coins and you're throwing them at once at the same time, and then you get a possible outcome. While this probability tree, it means you're getting 1 coin, throwing it 3 times. So here in our possible outcomes, we shall be having head, head, head. You are matching this with this. So then here we also have head, head, tail. Then this one and this one we have head, tail, head. This with this we have head, tail, tail, like that. So at the end of it all, tail, head, head. Then we also have here tail, head, tail. Then tail, tail, head. And we also have tail, tail, tail. So when you count your outcomes here, you still come to the same 8 outcomes. 1, 2, 3, 4, 5, 6, 7, 8. You still have the same outcomes. So the table works when you have all of them being thrown at the same time. But for the tree, works for when you're throwing one at a time, one at a time, one at a time. So this is what you will come up with. Someone might ask, why are we putting these ones as 2? You are doing these ones as 2 simply because there is no way we can, remember we are matching just this to the other. So literally you're going to end up with the 2 being thrown here, then you also get the other one and then get the possible outcome. That's how the tree is drawn up. So members, that is how we are dealing with our probability. I don't know, I hope I've answered most of people's query. Maybe Mary is not covered. Mary, before we look at what we need to look at today, Mary?
Teacher, I just forgot my hand up.
Okay, thank you. So members, that is how we deal with our probability. Now today we are moving to look at the coin. I sent out those notes, and I hope people were able to check through. Okay, I hope people check through those notes. Now, okay, I think let's concentrate a little. Let's concentrate a little here. Now, when we have our Okay, so we are here. So today I want us to look at the die. I want us to look at the dies. That is what I want us to look at today. How do we deal with our dies? So let's look at our screen here. Let's check out our screen here. Okay. So today I want us to look at what do you do when you have a die, when you are tossing a die, whether once or twice. Now, members, when you have a die, when we are going to look at tossing a die twice. Sorry, we are going to look at tossing a die twice. Okay, we are there. Okay, so I'm saying we are going to look at how we can deal with our die. What happens when you have a die? So remember, when you have a die, one die has 6 faces. Okay, one die has 6 faces. Now, those 6 faces, each of them, every time you toss, the face can come. And the faces have numbers ranging from 1, 2, 3, 4, 5, up to 6. Okay, this is what you have. I hope we are able to see the screen. Are we seeing our screen? Are we seeing the screen? Yes, we can. Okay. Yes, sir. Okay. Thank you. Good. Thank you. So we are saying when you have your die, when you throw it, every time you throw it, you'll always have these outcomes here. One of them at least will have that. And of course, the probabilities they can ask us is, can we get the probability of an even number? Okay, you count how many even, remember the sample space, the number of the sample space is always here, it is 6 here. Okay, that's our sample space. So the number of events, okay, for example, if they say for even number, if you need us to find out the even numbers here, you count how many even numbers you have. We have 2, 4, and then 6, so meaning there are 3. So you put 3, that is our number. So meaning with the probability of the even, probability of even will be the number of the even, which is 3, out of the sample space, which is 6. It is quite easy done. Now, a scenario is going to come. What happens when you have 2 dice? You have 2 dice, and you've been told to either throw them at once or throw them one by one, and they tell you what are the possible outcomes. What sample space shall we get? Okay, so that is what we are going to take a look at. So when you have a die, when you're having a die, when you have 2, if the dice are 2, please don't mind about the notes. I'm going to share with you the notes thereafter. Okay, let me clear something here. All right, so we are saying that when you toss a die twice, we have a die and we are tossing it twice. What task do we have ahead of us? How do we generate them? We have the possible outcomes. We also have to generate a table of the products. We also have to generate a table of differences. We can also generate a table of sums, or when you add up. To start with, I want to begin with the first one. What are the possible outcomes in a table? What outcomes do we get when you get your die and you toss it twice? Okay, or you have 2 dice and you're throwing them at the same time. what are the possible outcomes that we are likely to get. Now, here we are. So to generate our outcomes, we need to draw a table, okay? We need to come up with a table, okay, in that form. So in this table here, you're going to write, we have die 1, and we also have die 2 here. So in those two, you write the numbers that are there. So on day 1, we have first 1, 2, 3, 4, 5, and 6. Then on day 2, you also have the same 1, 2, 3, 4, 5, and 6. This is the first thing we have. So you draw that given table first. Okay, so this is the first table we first generate. Okay, so when you have this table here, it is going to help you to come up with your, sorry. So when you have your table here, let's have it this way. So this is our table, and we are told to come up with the possible outcomes when you toss two dice. So we are going to generate something like this. Now, when we are throwing this, when we are throwing the dice, what are we going to have? For example, so we keep matching this one, first die, second die, first die like that with the second die. So the way we've been doing with the head, tail, and so on. It's the same thing we are doing here. Okay, it's the same thing we are going to keep on doing. So how do we okay, so how do we generate this? So we are going to say this and this will be our first outcome. So we shall have 1, 1. Okay, then still we go to this one here. We shall have here now 1, 2. This and this one here, we shall have 1, 3. Then 1 and then 4. Then we also have 1 and 5. Then we also have 1 and 6. This is our first line. This is those are all possible outcomes that are going to have that will have the 1 and the 1 for the first and the second dice. Now, let me request someone to give us the outcomes in our next line. Joan, your hand is up. Yes, Joan? Joan? Oh, Joan is not there. Yes, Muhindo Esther, can you unmute?
Yes.
So can you now? Are you there?
We're going to have 2, 1. Yes, and then.
Okay, so we have 2, 1 here. Good. Then here we have 2, 2.
3.
2, 3.
2, 4.
2, 4.
2, 5.
2, 5. Good.
Then 2, 6.
Then 2, 6. Then here
we have 3, 1.
We have 3, 1. Good.
3, 2.
3, 2.
3, 3.
3, 3.
3, 4.
3, 4.
3, 5.
3, 5.
3, 6.
3, 6. Good.
4, 1.
4, 1.
4, 2.
4, 2.
4, 3.
4, 3.
4, 4.
4, 4.
4, 5.
4, 5. Correct.
4, 6.
4, 6.
Then 5, 1.
5, 1.
5, 2.
5, 2.
5, 3.
5, 3.
5, 4.
5, 4.
5, 5.
5, 5. Then here
5, 6.
5, 6. Correct.
6, 1.
6, 1.
6, 1. 6, 2.
6, 2. Good.
6, 3.
6, 3.
6, 4.
6, 4.
6, 5,
6, 5,
then 6, 6.
then 6, 6. Thank you. All right, thank you. So,
Welcome.
so members, these are now the possible outcomes that we shall have when you try to toss out that die, that when you toss out that die twice, okay? So when you get that outcome, you can now answer any question, okay? We can now answer any question that comes out. For example, you can be told, what is the probability of finding odd numbers only? Yeah? The probability of odd numbers only. So, hey, maybe before we do that, maybe before we get that probability, what is the number of the sample space? What is the number of the sample space? What is the number of the sample space? Someone's hand is up. Becky? Yes, Becky? What's our number for the sample space?
36.
36. Good. So, when we look at our sample space, we are saying, count all these ones here. Count the 1, 1, 2, 2, this and yeah. So we count this one as, this is 1, 1, 2, 3, like that. You count each of those boxes until you get that 36. So you're saying you can be given any probability from that point. Okay, you can find any probability. They can say, what is the probability of finding odd numbers? Odd numbers, only odd numbers. So first of all, we find the number for the odd numbers. How many odd numbers are there only in our combination? Someone to tell us, when you look at our table there, which one gives us only odd numbers? Only odd numbers. Who can tell us? Who can tell us? Yes, Ronnie. Ronnie? Yes, Ronnie? Unmute. Hey, Ronnie is not there. Morunji Davis.
18.
First tell us first count for, first give us which ones. On the first line, which ones are odd numbers only?
1, 1.
We have 1, 1.
1, 3.
1, 3. Good.
1, 5.
1, 5. Good. Second line.
2, 1.
Is 2 an odd number? We need odd numbers only. Meaning, like for example, here 1, 5, 1 is an odd number, 5 is an odd number.
3, 1.
So on the second line, do we see any odd number?
No.
We don't have any odd number. Then here
3, 1.
we have 3, 1.
3, 3.
3, 3. This was 3, 3.
And 3, 5.
Then 3, 5. Good.
Yes.
Do we have any on the fourth line?
No.
No. Then fifth.
5, 1.
We have 5, 1.
5, 3.
5, 3.
And 5, 5.
And then 5, 5. Next line, do we have any?
No.
No. So in total, how many have we circled?
9.
9.
We've circled 9. Good. So meaning the number of the odd numbers only that we have there, okay? The odd numbers that we have only there are 9 in total. So meaning you first get the number. So meaning now the probability of the odd numbers only will be equivalent to the number of the odd numbers only out of the number of the sample space. Okay, so this will be equivalent to 9 out of the sample space, which is 36. It is okay, you can reduce this down. If you can reduce it, reduce it. If you can't, then you can also leave it there. But it is advisable you reduce it down further. So this is how we are generating our, this is how we are generating. This is how we are generating. And someone has said it is 1 out of 4. Good. Okay. Okay. I think this is how we are generating our sample space. So you can, any question can arise. Give a probability that all numbers are the same. Give the probability that the all numbers have even and odd like that. So you can just circle and then you give us the number. So these are the possible outcomes when you toss the coin once. Okay, unless someone has a question about these outcomes here. Donald, any question? Do you have a question? Donald, do you have a question? Pardon? Oh, we lost you. Your network isn't good. Is probability reduced? Yes, you can reduce it. Yes, you can reduce it. Yes, you can reduce it. It is very fine. It is actually advisable for you to reduce it. Okay, we have another person. Who do we have here? Deborah? Deborah, you have a question?
Yes, sir. No, I don't have a, I heard you ask a question.
Okay. Felix, have a question? Felix,
Yes.
You have a
Yes.
question? Your hand is up.
Yeah, Mito, I just wanted to ask if you can reduce the probability.
Okay, you can do so. You can reduce it.
Okay.
Good. So, so members, this is what happens for that. Now, another thing, what happens? Remember, we've now generated the one for the possible outcome. We have our possible outcomes. Now, what happens if you get the products? We need to generate also a table of products. So we can ask you from here that what's the probability of finding a product of maybe 20 or a product of 10? Meaning you are supposed to add the number, you are supposed to multiply them, and then you get the results. Okay. Now we need to generate the table for products also. So we said this is our table for the outcome. These are our possible outcomes. We are done with this. Now, what is the one for the products? The table for the products. Products meaning that is multiplication. It means that when you toss 2 dice, when you multiply the number from one die to another one, you'll get a certain number, meaning that's the product now that we are looking at. So how do we generate that table also? So to generate that table, we still follow the same thing. We do the same thing. You draw up your table still. We have this. So this is here, you put the multiplication sign. Then this is die 1, and also this is die 2. So we have 1, 2, 3, 4, 5, and 6. Then we also have here 1, 2, 3, 4, 5, and then 6. So you draw up your table in that order. So members, it is very important that before you start calculating the probability, first get the possible outcomes. Don't start calculating, not even assume. Get your outcomes first. Get to know that in the outcomes, this is what I expect. So from what I expect, I can get such and such any outcome. Okay. So we are also going to generate the possible. So here what we are doing, we are multiplying. You can say dice 1 times dice 2. Dice 1 times dice 2. So we begin, like for example, I'll say, you can even change. The multiplication is the same. When you say 1 times 1, then so you get the same thing. So we start saying what? 1 times the 1. 1 times 1, you get 1. Okay? Then you get 1 times 2, you get 2. Then 1 times 3, you get 3, like that. 1 times 4, you get 4. 1 times 5, you get the 5. Then 1 times the 6, you get 6. That line is done. Then you go to 2. 2 times 1, you get 2. 2 times 2, you come to 4. 2 times 3, you get 6. You keep moving on and on. Now, I want someone also to come and complete for us the table. Okay, who can complete for us the table? Gracious. Gracious has gone. Nina Diana? Nina Diana is not there.
Yes.
Are you there?
Yes.
Can you complete for us this? Can you complete for us this table?
2 times 4. 8.
We shall get 8.
5 times 10.
10.
10. It's 10.
2 times 12. 2 times 6.
It is 18.
2 times 6.
Sorry, 16.
2 times 6. 2 times 6. That's 6. 2 times.
12.
Good. It is 12. Move next line. 3 times 1.
3.
3 times 2.
3.
3 times 2.
6.
Come to 6.
6.
3 times 3.
9.
9. Good. 3 times 4.
12.
3 times 4.
12.
3 times 5.
Yes.
15.
15.
Good. 3 times 6. 3 times 6.
18.
We get
18.
18. Good. We come to 4. 4 times 1.
4.
That's 4
4.
times 2. 8
8.
times 2. 8. 4 times 3.
12.
12. Good. Times 4.
16.
16. Times 5.
20.
We get 20. 4 times 6.
24.
Is 24.
4.
We go to 5.
5.
Times 1 is 5. Times 2.
10.
10.
15. 3 times 5, 15.
15.
4 times 5, 20.
20.
4 times 5, 25.
25. 4 times 5 times 6. 5 times 6. 5 times 6. Hey. Nina has disappeared. Nina is gone. Nina, is still there? Yes, Nina? Okay, we lost Nina. Philomena, can you complete? Philomena? Yes, can you complete? Will you complete the table?
5 times 6 is 30.
30.
Yes.
Then we come here. 6 times 1.
6.
Times 2.
12. 12. 18.
Times 18.
24.
24.
30. 36.
36. Thank you very much.
Welcome.
So, So members, this is how we are generating our outcomes. So when you draw your table of products, you can say, what's the probability of finding a product of 12? Probability of finding a product of 12. So you look at the outcomes, how many 12s are there in our table? So you look at the number of the probability of 12, the numbers of 12s, how many 12s are there? You see, this is 1, we have 2, we have 3, we have 4 here. So meaning there are 4, so meaning the number is 4. Then meaning our probability will be, our probability of 12 as the product of 12 will be the number of the product of 12 out of the number of the sample space. So this will be equivalent to 4 out of 8. Our sample space is 3060. Right? Our number of the sample same as the other outcome, meaning to be 4 out of 30, 4 out of 36. You can reduce this down. It is very fine. You can reduce it down. So if they ask for a certain product, or what is the probability that the product is an even number, or what's the product is an odd number, you just look for odd numbers and even numbers, and then you give out your given answer. So that is how you generate the table for the products. How about when you're asked to find the probability of a product of 14? Hey, someone is asking, Infinix, what's the probability of 14? So look through your products here. Do you see 14? No, meaning it is 0 out of 36, meaning it is not there. Okay, the probability is of 14. Probability of getting the product of 14 will be 0 out of 36, because when you look through in your sample space, you do not see anything like what? Like 14. So meaning that's what you will end up coming up with. Okay. I think, what if you just write 0? It is okay, you can just write 0. Okay? You can just write 0, meaning that probability is not there. It is impossible to get a product of 14, because in all multiplications, there is no way you can get that, that 14 anywhere. Okay? So class, this is how you generate your table. Now, I'm sure all of you can now, you can now, based on that, based on what I've given you, maybe let me answer some questions. Yes, Bena, you have a question? Bena.
Sorry, I just forgot my hand up. Sorry.
All right, fine. Elizabeth? Okay, Tom? Yes, Tom? Tom, you have something? Tom, can you unmute? Okay, Olivia? Yes, Olivia. Nalunkuma, Olivia. You have a question? Yes, Olivia?
I just forgot my hand up.
Okay. People are forgetting their hands up, eh? Hey. Tendo. Has Tendo also forgotten their hand up? Yes, Tendo? Oh, Tendo has also forgotten the hand up, eh? Yes, Tendo. Okay. Tendo?
So how do you get 36?
From where?
From the table.
It is 6 times 6.
Oh.
Yes, 6 times 6. Okay, good. So class, this is how we try to come up with our probability tables for the dies. Okay, especially when they are true. Now, I am sure based on that knowledge, we can also proceed and find out the sum. Based on that, you can also do the sum. So when you're doing the sum and then the difference, so just quick, very fast, when you're coming up for the table for the differences, so if I ask what's the probability that the difference is 2, the difference is this is how you do it. So still you get this is your dice 1, and then this is your die 2. So what you do, you keep subtracting, yeah? You keep subtracting, okay? You keep but members, when you are subtracting, make sure you don't get a negative, yeah? Because we never have negative outcomes. We never get out negative outcomes. So look here, for example, here we are saying it is die 1 minus this. So we are saying 1 minus 1 is 0. 0 is okay in probability. 2 minus 1 is this. 3 minus 1, like that. Okay? Now, you see that when you come again here, when you come here, we are not going again using 1 minus this. No, we are now saying 2 minus 1, you get this. Okay? 2 minus 2, you get that. This, okay? This is what you're doing. So make sure in your table you don't get negative, because we do not have negative probabilities, negative outcomes. Your maximum is, remember on our scale when we started, we said our scale is from 0, we have half, and we have 1. Anything outside this, if you get a negative, if you get a 2 in your probability, then as your outcome, your possible outcome, then usually the negatives do not come out. So that's why we are saying that when you're coming up with your table, make sure you don't bring in the negatives. Make sure you're getting positive answers when you're subtracting. So when you do the subtraction, these are the possible outcomes that you'll get. So this way, when you see your outcomes are between 0 and what? Between 0 and 5. Not anything outside that. So you do the subtraction. 2 minus 1, get this. 3 minus 1, this. 4 minus 1, like that. Then you come to 5 minus 2, you come to 3. You see? 5 minus 3, you come to 2. Okay? 5 minus 4, you come to 1. And you see. So these are the possible outcomes. So when they ask for a probability, you still look at the outcome. But remember, our sample space is constant. For 2, our sample space is still 36. When you count through here, you still generate the 36. Then another table that you can be told to generate is this table of sums. Okay, the table for the sums. Following subtracting. Why don't you just no? So just take note of that. Take note of that we are not looking at the negatives. We are not looking at the negatives in our table. Okay. Whether you subtract and make it a positive, but make sure you don't generate a negative in your work. Okay. So you can also be told to generate a table of sums, totaling up, addition. So you can also add. What is the probability that the sum is even, that the sum is odd, that the sum is 8, that the sum is 10? You count how many 10s are in your calculation. So, but you do that after doing the addition. 1 plus 1, 2. 1 plus 2 is 3. Okay. 1 plus 4 is, 1 plus 3 is 4. 1 plus 4 is 5. 1 plus 5 is this, like that. So you do the same thing. 6 plus 1, you get 7. 6 plus 2, you get 8. 6 plus 3, you get 9. 6 plus 4, you get 10. 6 plus 5, 11, and so on, until you come up with your entire sums. So when you do that, in your probabilities, you can be told to get any of the probabilities that we need. So take an example. If you remember our questions here, there are some questions that laid across here in the beginning here. So if they say, I want us to calculate based on the tables that we have generated, what is the probability of finding a sum which is an even number? Okay. Then what is the probability of finding a sum which exceeds 10? And what's the probability of a sum which is divisible by 2 or 3. Let me work out one of them and then we shall easily. So we look, when you're to get this, look, go to your table of sums and you say which numbers are even in your sum table. Oh, let's look at our table of sums here. This is differences, and then we have sums here. So look for even numbers. Yeah? Let's look at the number of even. So please, it is advisable that you first mention the event first. You list the items first, then you get their number, and then thereafter you calculate the probability. Don't just look at the thing and then you say, the probability is this. So look at how many probabilities of the sums are even here. I want someone to give us an answer here. Moses, Egwedu Moses. Egwedu Moses, you're there?
Yeah.
So can you give us the number of even numbers in this term here?
Let's begin with 2.
Yes, we have 2.
4.
We have 4.
6.
We have 6.
8.
We got the next line. 8.
4 again.
Which one? This one?
In the second line, yeah. 6 again.
On the second line?
Yeah.
Good.
And then on the third line, we have 8.
You have 8.
6.
You have 6.
And then 4.
Then you have 4. Okay. Fourth line.
Fourth line, we have 6.
We have 6.
8.
8. Good.
10.
And 10. Good. Fifth.
Fifth, 6.
You have 6.
8.
8.
10.
Then 10. Okay. Then there's
we have 8 on the 6th line. Hello? Eight.
Yes, we'll take the 8.
10.
We have the 10. Good.
Then 12.
Then 12. Good. So those are the items. So the number is, how many are they? Count them. How many are they? Still counting? Ronnie says 18. Gloria says 17. Steve says 28. Hey, Joyce 18. 18. Galaxy 18. For you, how many have you got? The one who is counting. Okay, so the number is 18. Okay, so how are we counting this? We are counting the ticks, the ones we have ticked. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so meaning we shall say our number is 18. After counting and listing them, so the probability will be equal to the 18, the number. Deborah, yes, please do simplify. Okay. Ronnie says the probability is a half. This one, when you go into this, it is a half. Okay. Noted. And Charity also has got a half and so on. So So when you reduce this down, this is a once, and then this is twice, 1 out of 2. So that's our probability. So members, I would like us to, this is what we have to learn for today. And please, I'm going to post this work and then you go through it again on your own. I've tried to. Now, when they talk of which exceeds, you also look for the numbers that exceed 10. And then you count how many they are, and then you get the number. Divisible by 2, meaning you get the ones divisible by 2, and also those ones divisible by 3. You combine them together, and then you get your probability. Dear members, I think this is what we basically needed to have for today. Let me answer a few questions before we close our lesson. Let me start with, I'm going to move one by one. Yes, Ronnie? Ronnie?
Yes, sir.
You have a question?
Yes, so what is the, apart from today's lesson, I had this question all along, but I couldn't get a chance of asking. What is the formula for finding magnitude of vectors?
Oh, the magnitude of vectors. Now,
Yes.
I don't want us to mix this up. Could you please contact me up so that we can you can check through?
How am I going to contact you? Sir.